Welcome to myprojectbazaar.com. Now we discuss about the product combining generative and discriminative representation learning for lung CT analysis with convolutional restricted Boltzmann mechanics. Now we discuss the abstract for the process. The choice of features generally influences the performance of a tissue classification system. Despite this, many systems are built with standard and the predefined filter banks that are optimized for the particular applications. Representation learning methods such as Boltzmann mechanism may be standard filter banks because they learn a feature descriptions directly from the training data. Like many representation learning methods, restricted Boltzmann mechanisms are unsupervised and they are trained with the generative label objectives. This allows them to learn representations from the unlabeled data but does not necessarily produce the features that are optimal for the classification process. In this paper, we propose the convolutional and the genetic algorithm as well as segmentation for the morphological is also applied for the good segmentation and the feature selection methods. Thus, the classification is taken by the three type of classifications. Then the performance of the classification is finally evaluated by the performance metrics like accuracies, sensitivities and specificities. Then the classification accuracy in the range of above 90 or 95. Thus the process is well efficient for the lung disease classification. Most of the papers prefer the genetic optimization and the morphological segmentation method because the process is well efficient to identify the region of lung disease. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. The dataset is nothing but the folder which consists of the several images which is undergone for the process. After getting the input image from the dataset, the pre-processing is carried out. In the pre-processing, the median filter is applied. The median filter is used to remove the noise present in the input image. After the filtering process is completed, the segmentation is carried out. In this segmentation, we have to consider majorly three parts. First one is the morphological operation. Then the second one represents the fusion MAD algorithm, and the third one is represent the WHT algorithm for the segmentation. By these three segmentation, the lung disease region is segmented separately. In the feature extraction, we have considered the Gabor feature extraction method. The Gabor feature is the most efficient feature extraction method which is run as a 12 type of iterations. After getting the feature values by the Gabor feature extraction method, the optimization is carried out. In the optimization process, we implemented the genetic algorithm for the feature optimization. On the other hand, it is represented as a feature selection method. The most stable features are selected by using the genetic algorithm. After the feature selection method, the feature classification is carried out. In the feature classification method, there are three inputs are given for the classifier: test feature, train feature, and the targeted labels are given as an input for the classifier. After the classification process, we using the three main classifiers. First one is the SVM classifier, then naive Bayes classifiers, then the back propagation. The feature values are classified by these three classifiers only. After the classification result is shown in the text format, and the performance evaluations are also done for the accuracy, sensitivity and specificities. Now we discuss the initial running procedure for the process. First of all, open the MATLAB 2013. Now you can see the current folder, that is the current directory in the left side. In that you can see the file lung underscore disease underscore detection.m. Right click in that file and click the button run. Now the initial guide window was opened. In that you can see the several push buttons, that is the input image, median filter, morphological smoothing, fusion MAD, WHT, Gabor feature and the genetic algorithm and classification. Now click the button input image. After clicking the button input image, you can see the dataset folder, that is the test images. Select any one test image from the folder and click open. Then click the button median filter. Now the input image is loaded and as well as the filtered image is shown. In the figure 1 left side, the input image is shown as an title input image and the filtered image is shown in the right side with the title filtered image. Then click the button morphological smoothing. After applying the morphological process, the image is segmented. The original image is plotted in the subplot first and the other segmented like inversion, erosion, dilations are plotted. Now click the Fusion MAD technique. After clicking the button Fusion MAD technique, the fusion process is done and the segmented results for the Fusion MAD is shown in the figure 3. Now click the button WHT Fusion. Now the WHT Fusion images are shown in the figure 4. This is the original image and this is the WHT Fusion image. Now click the button Gabor feature. Now the Gabor feature extraction images are shown in the figure 4 and the figure 40. These are the 12 iterations I already in the abstract. Now click the button genetic algorithm. After clicking the button genetic algorithm, the optimization is carried out. After the optimization, the feature values are optimized and the optimized feature is shown save as an test feature. Then click the button classification. After clicking the button classification, we have to implement the three classifiers, that is an SVM, naive Bayes and the back propagation. First click the button SVM classifier. The output is affected, that is shown in the edit box 1, and click the button naive Bayes classification, that is also affected. Now click the back propagation neural network. The accuracy, sensitivity, specificity for the three classifications are shown in the figure 15 and as well as shown in the table format for the accuracy, sensitivity, specificities values.